Our blood pH is maintained within the range of 7.35 and 7.45, and the survival range is between 7.2 and 7.6. This is a very narrow range for the blood pH to be maintained. Why is this important? This is because of protein function. As we know, protein function is dependent on the shape of a protein. For example, let's take this enzyme. It has an active site. This active site must be maintained, and this is maintained by H bonds and R interactions, which are weak bonds. So if the pH is too high or too low, these bonds are broken and the protein loses its shape. As a result, it loses its function as well. We say that the protein is denatured. If majority of our proteins become denatured, then the body goes into decline and death is the result. Acid-base balance is like a chemical seesaw in our blood. When our blood is too acidic, it means that there are too many free H plus ions in the blood. So bicarbonate ions, which are already present in the blood, soak up the excess hydrogen ions and make the blood a little bit more basic, bringing the pH back to normal. The opposite happens when the blood is too basic or alkaline. In this case, carbonic acid, which is already present in the blood, releases the hydrogen ions, thereby making the blood pH to shift towards acidic and bringing it back to the normal range. Now let's take a look at the actual chemical equation of the acid-base balance that we just talked about. Water, when it combines with carbon dioxide, makes carbonic acid, which splits up into hydrogen and bicarbonate ions. H2CO3 is carbonic acid and HCO3 minus is bicarbonate ion. When the levels of carbon dioxide in blood increases, it combines with water and becomes an acid, which is carbonic acid. As we know, acids release free hydrogen ions, and so the level of free hydrogen ions goes up in the blood, making the blood acidic. The opposite is true for the bicarbonate ion. As we just heard, the bicarbonate ion soaks up the excess hydrogen ions to make this solution less acidic. And so the greater the number of bicarbonate ions, the more basic the solution. So if the level of bicarbonate ions in blood is high, it is a sign that the blood is basic or alkaline. And if the level of carbon dioxide in blood is high, then it is a sign that the blood is acidic. Here's our normal blood pH range, 7.35 to 7.45. Anything below 7.35 is considered to be acidosis, an abnormal condition in the blood. Anything above 7.45 is called alkalosis. These two conditions can have either a respiratory origin or a metabolic origin. If the condition is of respiratory origin, then it means that the carbon dioxide levels in the blood are either too high or too low. If it's of metabolic origin, then it means that the bicarbonate levels are either too high or too low. Now for the respiratory origin of acid-base imbalances. Respiratory acidosis is caused by too much carbon dioxide in the blood. When there is too much carbon dioxide in the blood, it combines with water and makes too much carbonic acid. So you end up with acidosis. This happens when a person doesn't breathe properly. In the case of asthma, emphysema, or bronchitis, the person undergoes hypoventilation, which means too little breathing. Respiratory alkalosis is the opposite. There is too little carbon dioxide in the blood, and when carbon dioxide levels are too low, less carbonic acid is made, and so the blood is more alkaline. This is due to hyperventilation or too much breathing. This can happen in situations of stress or even at high altitude. Now let's take a look at the metabolic origin of acid-base imbalances. We'll start with metabolic acidosis, which is caused by too little bicarbonate ions in the blood. When the bicarbonate ion levels are low, it leads to acidosis in the form of acid gain or base loss. Acid gain is caused in situations when a person has a prolonged fasting period, and base loss can happen when a person is experiencing prolonged diarrhea and the loss of intestinal secretions that tend to be alkaline. The next is metabolic alkalosis. Metabolic alkalosis is caused by too much bicarbonate ions in the blood. When the bicarbonate ion levels increases or it's too high, this results in metabolic alkalosis due to acid loss or base gain. Acid loss may be caused in situations when a person has prolonged vomiting and loses gastric secretions that tend to be acidic. Base gain can happen if a person is taking too many antacids. Now let's look at the metabolic origin of acid-base imbalances. We start with bicarbonate being low. When the bicarbonate levels are low, the pH is low as well, leading to acidosis. It would be metabolic acidosis. When the bicarbonate levels are high, the pH is high as well, and we have alkalosis, which is metabolic alkalosis. We have two types of buffers that maintain acid-base balance. We have chemical buffers that we came across earlier, which is the bicarbonate and carbonic acid, and we have physiological buffers. Now, the chemical buffers are very fast. They are already in the blood, they're instantaneous, and their effect is short-term. Physiological buffers are slow to react, it may take days, and they are long-term. Chemical buffers are in the blood. Physiological buffers take place in the lungs and the kidneys. The one that happens in the lungs is called the respiratory mechanism, and the one that happens in the kidney is called the renal mechanism.